Hi everyone, the following are the solutions for the sinusoidal equations package. So I'm about to solve it right now and follow along with me. Okay, so let's start with number 22. And I know this is not really arranged according to 1, 2, 3, 4, etc. But this is just how it's in my database. But anyways, so number 22. Part of the graph of y equals p plus q cos x is shown below. The graph passes through points 0, 3, and pi negative 1. So a good idea just is to sort of plot those points. So that's 0, 3. And then there's another point which is pi and negative 1, which I think it should be right here. So this is pi and negative 1. All right, so find the value of p and q. So if you observe over here, like the way I prefer to write this is I would have written y equals q cos x plus p, right? And from this, we know right away that this is the amplitude and this is the central axis. The central axis, right? So if you observe that these points that they gave us are really the max and min. The max here is actually the y-coordinate, which is 3, and the min here is negative 1. So if you remember the formula, the amplitude is equal to the max minus the min divided by 2. So in other words, it's 3 minus negative 1 divided by 2, so it's 4 over 2, which is equal to 2. So the value of q right away is equal to 2. Okay. Now let's deal with the central axis. If you recall the central axis, the equation for the central axis is equal to the max plus min divided by 2, which is equal to 3 plus negative 1 divided by 2, so it's 2 over 2, which is equal to 1. So p in this case is equal to 1, all right, because it's a central axis and we go that way. So always try to rearrange it if you can, and that personally for myself, it just makes it easier to understand. All right, so we're done with 22, let's go to 23. Okay, the graph of the function is equal to that. So let's write this down. So y is equal to p cos qx, okay? So if you recall, this is the amplitude again, right? And this is the horizontal compression, right? So we call the horizontal compression k, but it really just is the horizontal compression. Then this is just my own terminology. I could have called it m, p, a, abracadabra, or whatever, but I just prefer to call it k because it just sort of reminds me of compression. So anyways, the amplitude right here, again, this is the max, which is 30, and the min, which is negative 30. So I can pretty much tell right away that the amplitude, the central axis is right here, and that's the max, or so that's the amplitude is 30, and the central axis is 0. And we'll figure out what q is in a second. But if you want to use the formula and do it, so we know the max is 30 and the min is negative 30. So the amplitude is max minus min divided by 2. So the max is 30, the min is negative 30 divided by 2, so it's equal to 60 divided by 2, which is 30. You could read that off the graph, or you could figure it out. It's the same thing. So p is the amplitude, so it's equal to 30. Now q. If you recall, the equation that I sort of gave you in class is that the period equals 2 pi over k, where k was the compression factor, and we know that k is q, so it's really 2 pi over q, okay? So in order, if you want to find q, we need to know what the period is. So if we look over here, the period, this is just one cycle. This is one cycle. And we can see that from 0 to pi over 2, this is one cycle, so the period is equal to pi over 2. So if I had to write this, this would be pi over 2 is equal to 2 pi over q, okay? I can cross multiply, so in other words, it's q pi is equal to 4 pi, and so q is equal to 4 pi over pi, and if I cancel these out, I'm just left with 4. So q is equal to 4. So the answer to this, calculate the value of q is equal to 4, okay? So all I did was just basically some algebra. The period is equal to 2 pi over q. We found that the period from here, from this graph, let me just scroll up a little more. that P just means period, not, oh, actually, maybe I should clarify, just because I don't want to confuse you with this P with that P. So let me just write period equals pi over 2. So if the period is equal to pi over 2, then that's this one over here, pi over 2. Pi over 2 is equal to 2 pi over q. I did some basic algebra, and I got that q is equal to 4. Okay? So let's move on to the next one. So that was 23. Let's do 24. Okay. All right, the graph below shows P cos QX plus R. Some points are shown. There's a min here, and a max is there. Find the value of PQR. Okay, perfect. So let's just always write it out again. It's just a good idea to sort of identify what these things are, QX plus R. So this is, again, the amplitude. This is our compression factor K, and this is our central axis. Central axis, okay? So you can do this visually. Some people are able to do this visually. I just personally like to use formulas. So the amplitude is equal to the max minus the min divided by 2. Okay. What is the max over here? You might think the max is 4, but that's the x coordinate. We want the y coordinate for the max. So it's actually equal to 7. So the max is 7. And the min in this case is not the x coordinate, but the y coordinate, which is -3. So it's minus -3 divided by 2. So 7 minus -3 is 10 over 2, which is equal to 5. So the p-value, which is the amplitude, is equal to 5. Now Q is, remember, it's the compression factor K. So if you remember, period equals 2 pi over K. And in this case, since it's Q, it'll be 2 pi over Q. Now, what is our period? How do we find our period? The period is just one cycle. So over here, from here to here, if we see, like this point over here, the x distance from 0 to 4, this is a distance of 4. But keep in mind, this is not a full cycle. This is just half a cycle. So half a cycle is 4, so the full cycle will be another 4. So the period is really 8. And that's equal to 2 pi over q. And if I manipulate this, q is simply 2 pi over 8, which is equal to pi over 4. So this is equal to pi over 4. Okay, R is a central axis. And remember, with the equation for the central axis, I'm just going to write CA for central axis. This is equal to max plus min divided by 2. And the max is 7, as we said. And the min is -3, as we said. So it's plus -3 divided by 2. So it's equal to 7 minus 3 is 4. 4 divided by 2 is equal to 2. So R is simply equal to 2. All right? And that also sort of makes sense because halfway between -3 and 7 is 2. Okay. So that's the solution for 24. Let's go to 25. Let's do 25. All right, here's 25. So let f of x is equal to that. Okay, so this is kind of a tricky question. Let me just write these out first. Sine. So I'm going to put extra brackets because this really means stuff like that. Okay, x minus c. Okay, so A here is the amplitude. Okay, B here is the compression factor K. Sorry, did I finish that question? Oh no, sorry. Let me go back to this question. I didn't actually finish it. So 24b. So the equation y equals k has exactly 2 solutions. Write down the value of k. So I'm going to erase some stuff just because I need some room. So what they're saying is that this is the graph, right? And this k over here has nothing to do with that k over there. It just so turns out that we've chosen the same letter. But this k over here has nothing to do with that. So notice, y equals k has exactly 2 solutions. So write down the value of k. So y equals k, whenever y equals a constant, it means it's a horizontal line. Okay? So say, for example, if I draw, let me draw a horizontal line like right here. Okay? If I draw a horizontal line here, it says it has exactly 2 solutions. What that really means is how many intersection points are there? So here, if I draw the line there, I have 1, 2, 3, 4, and possibly 5 over here. But this says exactly 2. So where can I draw a horizontal line such that I only have 2 solutions? So if we draw it up here, we have 3. If we draw it anywhere, we actually always have more than 2. So the only place where we can draw it is literally right here across these 2 minimums. And that happens when y equals -3. So this is y equals -3. So the solution of k in this case is k equals -3. Okay? So that's the solution for B. Sorry that I skipped that a little too fast, but anyways, let's move to number 25. Okay, number 25. So here we are, number 25. Let f of x equals a sine blah, blah, blah. And if we write it this way, here's the amplitude, here's our compression factor k, and here is our phase shift. Okay? So now, what's very interesting is that they say that given that A, B, and C are positive, find the values of A, B, and C. Okay, so if we look at this, this is a sine graph, and if you recall, a sine graph has to, if it starts from the axis right here, it has to go up instead of going down, and this one goes down. So in other words, there's definitely a phase shift involved. Now, let's say we go to the left. In other words, we want this C value over here. So if we start over here, A will be positive because we have no reflection, right? And B will be whatever. But the problem is that C will not be positive. The reason why C won't be positive is because C in that case will be -π/2. And they said specifically that C has to be positive. So instead of going left, we need to go right. We need to do a phase shift to the right. So C will end up being π/2. The amplitude, since this starts at 0 and goes to 4 and -4, the amplitude will be 4. So A right away we know is equal to 4 because that is the distance right here because it goes up 4 and down 4. B is the compression factor K. So what that means is if you want to find B, we need to know what the length of one period is. So the length of one period, so one full cycle, it goes down, up like that. And so this is from 0 to pi, so the period is equal to pi. So the period is equal to pi. And remember what the equation of the period is. The period is equal to 2 pi over k, our compression factor. But this time we're going to call our compression factor B. So it's really 2 pi over B. So since we determined that our period is pi, so pi equals 2 pi over B. And if I solve for B, right, if I just interchange them, B is equal to 2 pi over pi. I just cross these out, and this is equal to 2. So B is equal to 2, which is also positive. Now finally C, as we said, we wanted C to be positive. We're moving the phase shift to the right so that because there is no reflection, we want this to go like that. So really, we need a phase shift, and the phase shift over here is pi/2. So C has to be pi/2. C is equal to pi/2. All right, let's move on to the next question, number 26. The graph of a function is given as below. So y is equal to p cos. And what I prefer to do is I always like to put brackets. Okay. So this is equal to the amplitude, and this is equal to their compression factor k. Okay, so write down the value of p. So as you can see, this goes from 30 to -30. Okay, this is actually the exact same question, I believe, as the previous one. But anyways, let's just do it anyways. So this goes from 30 to -30. So you can see that the amplitude is pretty much like here. This is halfway, right? So the amplitude, that was p, is really equal to 30. We don't even need to do calculations. We can just see it from the graph. Now calculate the value of q. So in order to calculate the value of q, which is the compression factor, we need to know what the period is equal to. So this goes from 0 to pi/2. So the period in this case is equal to pi/2. Okay? So if the period is equal to pi/2, so remember, the equation of the period is equal to 2 pi over k. And we said our k in this case is q, so it's really 2 pi over q. We've determined our period to be pi/2, so really it's just pi/2 is equal to 2 pi over q. Okay, and if I do some cross multiplication, it'll become q is equal to 4 pi over pi and this is equal to 4. So all you have to do is just cross multiply, and you'll end up with q equals 4. So q equals 4. So we're done with 26. Number 27. Now I know I told some of you guys you can sort of skip this question, but we can actually do a few bits of this question just by looking at this question. So anyways, let's sort of write this down. So f of x is equal to 1 plus tan x. So like I said before, the way I sort of like to write these kind of questions is I like to put the tan function or the trig function first. So it's tan, and since this is x over 2, we can say this is half x. All right, and then it's plus 1. So in other words, there's a vertical shift of 1. So on the same diagram, draw the asymptotes. Well, we can pretty much see what the asymptotes are right away. So let's just draw them right there. Kind of sort of an easy 2 marks that they've given you. And I believe this is sort of a very old question. I doubt they would ever ask this kind of question again. But anyways, those are the asymptotes, and we can see them right there. Now, the second part is write down the period of the function. Now, we can do this 2 ways. The first way is we can take a look at this period right here. This is from negative 180 to 180. So from negative 180 to 180 is 360 degrees. So the period right away is 360 degrees. Now, I know that we're used to sort of things in radians and things like this, but if I were to do this in radians, 360 is really just 2 pi radians. So the period of this function would be 2 pi. Now, here's the second way of doing it. We know that for tan, the regular period is not 2 pi like it is for sine and cos, but the regular period is simply pi. So if you remember, this is our compression factor k. So the period for the tan function, right, it's no longer 2 pi over k, but it's simply pi over k. And remember that pi is actually also 180 degrees, right? Pi is 180 degrees over k. K in this case is half, so it's equal to 180 divided by half, and 180 divided by half is actually 360, which is exactly what we have right here. Okay. The rest of the parts of the question we can't really do yet because we need some more knowledge in trig, but at least we can do a bit of this question. All right, number 28. The diagram below shows part of sine 2x. Now, here's one important thing, is that whenever they give you this function, draw like brackets around the argument. So maybe that's not the best. So I'll just write this right there. So it's sine, and then draw brackets around that and write 2x. Because it just sort of helps you sort of visualize what's inside the function. Write down the period of this function. So this is a sine function, not a tan function. So the sine function in this case is, or sorry, the period is equal to 2 pi over k. And we said this is our k value. This is our k value, our compression factor. So it's really 2 pi divided by 2, which is pi. So the period of this function is pi. Now, hence or otherwise write the value of m, which is over there. So if you observe, this is not a full cycle. This is actually half a cycle. A full cycle would actually go down this way and come up there. So this full cycle, we've already determined that the full cycle, the period, is pi. So if this is half the cycle, this must be pi over 2. So the value of m is simply pi over 2 because it's half the cycle. The full distance is pi, so half the distance must be pi over 2. Let's do. All right, number 29. Let's get on this. All right, so here's f of x, here's g of x, and let h of x equal g of f of x. So this is equal to g of f of x, and f of x is 3x over 2 plus 1. And remember that this is actually called the argument. So in other words, all we have to do is, since this is g of x, we take the argument and then we plug that into the x over there. So what this equals is then 4 cos something over 3 minus 1. And this something over here is really just, we're going to replace that x with the argument over here. So I'll just write this in red, just so it's clear. It's 3x over 2 plus 1. We're just replacing the x over there with 3x over 2 plus 1. Now, the thing to do here is just to simplify this expression as much as possible. So what I'm going to do is I'm going to divide each of these by 3. So this is going to be 3x over 6. Because 3x divided by 2 divided by 3, it's like you just multiply the 2 and the 3, so you get 3x over 6. And this is plus and this is the 1/3, so just simply 1/3 minus 1. Now if you notice that 3 over 6 is just really half. So another way of writing this is simply 4 cos half x plus 1/3 minus 1. And I'm going to factor this out. So this is going to be 4 cos, this is going to be half. I'm going to factor out x plus 2/3 minus 1. All right? So there's our expression of h of x. So we're done with that. Now, write down the period of h. So in order to find the period, remember that we need to first find what the compression factor k is. This is our k, so k is half. And if you recall, the period for a cos function is 2 pi over k, and it's 2 pi over half, which is equal to 4 pi. Let's go to the, excuse me, just sneezed right there. But anyways, that's the period of h. And now write down the range of h. So in order to write down the range of h, we look at this function a little bit, and let's sort of graph it. And we don't really need to graph it exactly, but here's our xy axis. Our central axis is -1, so I'm going to use a black pen maybe for that. Right, so it's -1. The amplitude is 4, so it goes up 4 above, so it goes up all the way to 3. The reason it's 3 is because -1 plus 4 is equal, so this is a 4, this is the amplitude, so -1 plus 4 is equal to 3, and it will go as low as -5, and it's -5 because -1 minus 4 is -5. So in other words, now we have a phase shift of 2 over 3, and it's a cos function. So anyways, it'll look something like this, and you know, it'll keep bouncing like this and so on. But anyways, our range is from -5 to 3. So really the solution, the range, is y, the lowest value is -5, and the highest value is 3. And that's our range. Okay, so we've basically solved part C here. We've basically solved part C here, and we're done. So let's move on to the next question. All right, so number 30. So let f of x equal to 6 sine pi x and g of x is equal to 6e -3. The graph of f is shown in the diagram below. There's a maximum value b here. So this point right here is 0.5 comma b. Okay, write down the value of b. Well, if you look at this, this is our f of x function, and the amplitude is 6. So if we, another way of writing this, another way of writing f of x is really just 6 sine pi x plus 0. So in other words, because there's no 0 here, they'll never write plus 0. So in other words, our central axis is 0, right? So our amplitude is actually 6. So in other words, it goes as high as 6. So this distance will be 6. So our b value here must be equal to 6 because that's the maximum. So b is equal to 6 because 6 plus 0 is 6. On the same diagram, sketch the graph of g. Okay, so what I need to do is I actually just need a little bit of room, so I'm going to erase this. I'm going to erase this right here. I'm going to erase this right there. And the thing is, this type of question, sketch the graph of g. G is this function right here. If you remember, this is a exponential function. So -3 means that's where the asymptote is. So -3 would be somewhere over here, and so there would be a horizontal asymptote right around here. Okay, and 6 to the e to the -x minus 3. So in other words, since there's that -x, it means it's decaying. Okay, so it would go something, probably something like this. I'm assuming. Now, this most likely is a paper 2 question. So what I'm going to do is I'm actually going to graph it myself and just make sure that this is correct. But you can graph it along with me. So just plug in 6 pi x. I'm just actually doing this as we speak. 6 pi x. And then for y2, you can plug in 6 e to the power of -x and then minus 3. And if you change your windows to say from 0 to about, I don't know, like this is from 0 to about, say, I don't know, say 2.5. And the y's should be from, say, something like -6.5 to 6.5, just so we can see the window range. So, and I'm just double checking it's graphing on my calculator as we speak. And yeah, so that's basically what the graph would look like. So this most likely would be a paper 2 question. So instead of even knowing how to sketch an exponential function, you could have just graphed this and then copied that graph onto the chart over here. And because they said sketch. And we definitely know this is a paper 2 question because this says f of x equals g of x. So f of x is 6 sine pi x is equal to 6e to the negative x minus 3. Honestly, we haven't learned any techniques, and neither will you learn any techniques in this course to solve this. So if this is a paper 2 question, the best thing to do is to actually plot this on your graph and solve this using your graphing calculator. Now, the important thing is to pay attention to the range. They said it's between 0.5 and 1.5. If this is 1, and this is 0.5, and this is 1.5, the only value where this intersects is right here. So you might get you can see there's an intersection point here and an intersection point here, but the domain, or the one that they are interested in, is only between 0.5 and 1.5, so that's our solution. So what we can do is you can just use your intersect sort of function in your calculator, and what I'm getting is that x is equal to 1.05, and you can say, the way you just write this is using GDC. Okay, so what that means is using a graphing display calculator, you obtained this equation, or you obtained the solution, and that's enough. That's all you have to say, especially if it's a paper 2 question, because paper 2 expects that you will use a calculator. Okay, all right, so let's go to number 32. Sketch. Okay, so here we go. Here we have 3 sine x plus 4 cos x. Sketch the graph of f. I'm assuming here that this would be a paper 2 question, so because that would be something that's really kind of hard to sketch. So you can do 3 sine x plus 4 cos x, and they said that it's between negative 2 pi and 2 pi. So make sure that your x min in your window is from negative 2 pi to 2 pi. I'm actually graphing this as we speak. And so I have a little graph right here, which kind of looks like this. So, oops. So I'm just copying this off my graphing calculator. And if this was a paper 2 question, this is pretty much what they would expect. So it pretty much goes up to about like 5. This is what I'm observing from my graphing calculator. Negative 5. Basically, we get something that looks like this. Right? And this goes down here and up here, something like that. So I just graphed this from my graphing calculator. Simply plug that in, put this in your window range, and make sure you have the y min and y max, like something that you have over here, and sketch it, and you should be fine. Okay, write down the amplitude. So what I can see from here, just based on this graph, is that the central axis is pretty much right around 0. So the amplitude, and it actually, if you check, you can actually find the point right there. The amplitude is pretty much, it goes up to 5. So the amplitude here is actually 5. Now, if you want to find the period, the best way to do this is find one point over here and find another point over there. Or you could have found one point over here and another point over there, and use your graphing calculator to do this. So I'm actually just tracing this right now. I'm going to do these bottom points right here. So you can find the minimum of one point right there. So say minimum left bound. You can find the right bound, and there you go. So this point right here is negative 2.49. And now let's go all the way to the other point, which is somewhere close to 3 actually. So let me get the exact value. Left bound, right bound. So it's 3.78. Okay? So in other words, all I have to do to find the period is I subtract 3.78 from 2.49. So the period in this case is equal to 3.78 minus negative 2.49, and that's equal to 3.48 minus negative 2.49 is equal to 5.97. So the period in this case is equal to 5.97. The x-intercept that lies between negative pi over 2 and 0. So once again, you can just use your graphing calculator here. Negative pi over 2 and 0. So if you go and type in negative pi over 2, which is somewhere over here, and 0, which is obviously here, you can figure out where the x-intercept is. So you can just go to, if you have a TI-84, just go find the 0. So choose your left bound, choose your right bound, and the point that I'm getting, which is this point right here, is negative, so 0 or negative 0.927. 0.927. So the x-intercept here is negative 0.927. All right, and again, you can just pretty much use the graphing calculator to get this. All right, hence write the function, write f of x in the form p sine qx plus r. Okay, so in other words, we have all the information that we need because p, if you think about it, is the amplitude. And what did we get for our amplitude? It's 5. What's our period? Our period is this, right? Our period is 5.97. And so let's actually solve it this way. So we have p equal, so actually I'm going to solve it this way. So we have our amplitude, and the negative 0.927, that's basically our phase shift, and it's our phase shift to the left, if you observe, because it's to the left. So in other words, our equation is our amplitude, which is 5, and it's sine, okay? Now, we need to find what our k value is. So remember, the period is equal to 2 pi over k. So k is really 2 pi over the period. And in this case, it's 2 pi over, the period is 5.97, so 5.97. So it's equal to 2 pi over 5.97, which is 1.05, so 1.05. So really this k value here is 1.05. There's a phase shift to the left, so it's going to be x plus 0.927, 0.927. Okay, I'm just going to erase this because I just need a little bit more room. So, I'm going to erase this because I need a little bit more room. And if you observe over here, this is not in factored form. This is actually an expanded form. So this is equal to 5 sine 1.05x, and then 1.05 plus 0.927 is plus 0.973. So this is our solution. It's different from what we have here. So that's how we do part C. Now, write down one value for x such that f of x equals 0. Oh no, this is f prime. So you don't have to deal with that because we're not dealing with integrals right now. Or sorry, calculus right now. Part E, write down two values of k for which the equation f of x equals k has exactly two solutions. So if I sort of look at my graph, and what I can see is write down the two values. Okay, so basically this is very similar to a question that we've done before. So what it really means is basically find if f of x equals k, it's just a horizontal line. So write down two values of k. So in other words, find two horizontal lines where you have exactly two solutions. Well, see, if I draw a horizontal line like here, I have 1, 2, 3, three intersection points. So definitely this is not the line. So the two lines where I'll have exactly two solutions are, I'm going to remove that green line so it's not confusing, is over here. So basically when k is equal to 5, and over here because it hits those two minimum points. So k will be 5 or negative 5. And that's the solution for C, for E. Okay? And F we don't have to do because once again, it refers to calculus, so we don't have to worry about that. So make sure you understand E, because these kind of questions are really popular, where they say, like they mention it where there's an equation f of x equals k has this exact number of solutions. It really means there's a horizontal line, and you got to find that horizontal line or the value where you only have 2 solutions or so, or however many solutions they ask you for. Okay, number 34, f of x is that, g of x is that. Write down the minimum value of the function of f. So f of x is equal to sine 2x, right? So if you sort of sketch it out, it's really plus 0. So its central axis is 0. Its amplitude is really 1. So it goes max of 1 and as low as -1. So the minimum value of f is -1. So that's the solution for this one. The period of the function of g. So if we look at g, this is g right here. So, so g of x is equal to sine of 0.5x. So if you remember, this is our k value. So the period is equal to 2 pi over k. So in other words, it's 2 pi over 0.5, which is equal to 4 pi. Okay, so this is equal to 4 pi. Consider the equation f of x is equal to g of x. Find the number of solutions to this equation. So between 0 and 3 pi over 2. One way of doing this is, I'm not sure if this is a paper 1 or a paper 2 question. Something tells me that it might be a paper 1 question, but let's try. We actually might need a bit more information. We actually might need a little bit of trig to sort of do this. The easiest way, let's assume that for now that this is a paper 2 question. So the easiest way to do this would be to actually graph both functions f and g, and over this domain, and see how many solutions that we have. So I'm just going to plot this in my graphing calculator right now. So there's sine 2x, and then there's sine 0.5x, and make sure that it's from 0 to 3 pi over 2, and I'm going to put this from -1.5 to 1.5. It's graphing as we speak. So basically what I see is, I see something like, because this says only from 0 to 3 pi over 2. So for one function, I see something like this. And then for another function, I see something like this. So what I see is that there are 3 intersection points. So 1, 2, actually no, there are 4. 1, 2, 3, 4. So there are 4 solutions. So there's that over there, that over there, that over there, that over there. So I did this through graphing, and maybe this is cheating a little bit, but the best way is actually if you can graph it. So if you can draw a little sketch of 1.5 cycles in this case, then you might be able to get the equation in this case. So in this case, the answer is 4. Okay, so let's do 37. Let me move up a little bit. Okay, so let f of x equals that. Now that is not factored. So the most important thing right now is to factor it. So f of x is equal to sine of 2x plus half. Okay, so what that tells you is the amplitude is 1, the k value is 2, so the period is going to be 2 pi over 2, which is equal to pi, so you know the period is pi. There's a phase shift of 1/2 to the left, okay? There's a phase shift of 1/2 to the left. So, and show the sketch of the curve on the grid below. So really what we should be doing is, it really should start like -0.5 here. The period, the amplitude is 1, so it's here, and the period is pi. So in other words, if we start at -0.5, we need to end up like pi away. So pi would be, so -0.5 plus pi, in this case, is 2.64. So actually I have it a little less than over here. So it should be, goes all the way to 2.64. So that's basically one full cycle. So if that's 2.64, so let's just say this is where it's going to end. So that's 2.64, 2.64. So now we need to find the middle point. The middle point will be the average of the two. So it's 2.64 plus negative 0.5. And then that divided by 2 will be 1.07. So 1.07 will be somewhere here. So 1.07. This actually might be a paper 2 question, so where they're asking you to sketch. So if it was a paper 2 question, then this would be actually pretty easy. All you'd have to do is just sketch it. So what I would do is, or just graph it and then sketch it. So anyways, this is where it's going. The max value will be somewhere in between. So let's just say it's somewhere here. And then the min value will be somewhere in between, so somewhere here. Okay, so I'm going to graph this. It's going to be something like that. Right, and then something like that. My pen is not the firmest, so it's a little bit shaky. But the important thing is you should not graph this part, because the domain over here says from 0 to pi. Oh shoot, it only said from 0 to pi. So I actually need to continue a little bit further, because pi would be 3.14. So it actually would go somewhere like this. And the thing is, you have to keep in mind, because they said from 0 to pi, you can't include anything that is before 0, nor can you include anything after pi. So it would pretty much stop right there. Okay, I'm pretty sure that this is a paper 2 question, so you would be required to use your graphing calculator. And if you had your graphing calculator and you put, your x and y, your x min, x y, and your window range basically nice and neat, you could just copy this literally from your graphic display calculator and just plot this, and you would get full marks. Okay, this was just extra information just to show you sort of how to do it if it was a paper 1 question. Find the x-coordinates of the maximum and minimum points of f of x, giving your answers correct to 1 decimal place. Now, for sure, whenever they say decimal place, you know that this is a paper 2 question, because only a paper 2 question would ask you for decimal places, which means that you need a calculator to solve this. So the way you do this is you basically have your graph. So I'm just actually plotting this as we speak, and our function once again is sine 2x plus 1. So sine 2x plus 1. My window range should be from 0 to pi. And I know, and I'm basically just going to choose what they have over here, which is from negative 2 to 2 to 2. So negative 2 to, oops. I'm just changing things in my calculator. Negative 2 to 2. And I see basically this graph forming. And since they asked for the min and max, so this is basically the max. So all I'm doing is just using the calculator functions to find the max point. Find the max point. So here's my left bound. I'm sort of just doing this as we speak. I wish I could show it to you actually how I am doing it, but maybe once I get the software for the calculator, I can do that next time. So this point right here, and this is just me using the maximum function in the calculator. This is 0.285, comma 1. So this is the coordinate of the max point. Now for the min point, you just basically are just doing the exact same thing. So you're using now the minimum function in your calculator. So minimum left, right. Okay, and so this point is 1.86. Remember, you want 3 significant figures, and the y coordinate is negative 1. And those are, but be careful. The question said to only find the x coordinates. So if I just want the x coordinates, they are simply x equals 0.285, and this is for the max. And for the min, it's x equals 1.86, and this is the min. So please pay attention to what the question is asking for. The question here specifically asks for the x coordinates, so that's how you get the max and min for this, and it's to 1 decimal place. Okay, so I made a mistake. So really, it should be x equals 0.3 for the max, and x equals to 1 decimal place. So this would round to basically 1.9 for the min. Okay, so always pay attention to what they're asking for. They ask for the x coordinates, so don't give the y. And since they said one decimal place, that's basically all you need to give. And that's how you do that question. All right, we're nearing the end, actually. Just a few more questions. Write down the period of g for this function. This is k. The 2 is the k. So the period is equal to 2 pi over k. And our k in this case is 2, so it's equal to pi. So the answer to this is pi. On the diagram below, sketch the curve of g from 0 to 2 pi. So what we know from here is that the amplitude is 3. We know our period is pi. And we know that, so this is our central axis. Okay. Our max will be 3 higher than that. And our min will be 3 lower than the central axis. Okay. We start from 0 because it's sine x. There's no phase shift or anything. So we're going to start from here. Okay. And we're going to end pi away. So we're going to end pi away. And our midpoint is going to be pi over 2. So we're going to draw one cycle pretty much like that. And then it's going to go like that. Now, pay attention to the question. The question said to go from 0 to 2 pi. So we have to keep going till they want us to stop. So in other words, this cycle will continue. So if you basically, this is where it'll end up. So we just continue the cycle, it goes there again, because it's going to be pi away further. So if it ends at pi, one more cycle will end at 2 pi. So it goes like that, and that's where we end. So this is 2 cycles of pi, and that's how we solve b. Now there's a c. Write down the number of solutions to the equation g of x equals 2 from 0 to 2 pi. So when they say g of x equals 2, what this means is this is like saying y equals 2. And y equals 2 is a flat line. So let's draw this. So y equals 2 just looks like that. And they're saying this is from 0 to 2 pi. So basically we stop there. So how many solutions just means how many intersection points that we can see. So we see 1, 2, 3, 4. So the answer to this question is how many solutions? The answer is 4. Anytime they ask number of solutions, it just means how many intersection points do you see between, in this case, a horizontal line and the curve that we have over here. Okay, let's do 40. So here's our f of x, here's our g of x. On the same diagram, sketch the graphs of f and g. Okay, so what I'm going to do, I'm pretty sure this is a paper 2 question. So first, the best thing to do is graph 5 cos pi over 4x. Okay, and this one is negative 0.5 x squared plus 5x minus 8. I'm literally just graphing this in my calculator. And just make sure that in your window range you have from 0 to 9. So the x min is 0, the x max is 9. And for the y min, well, we know the amplitude is 5. So we pretty much know it should be somewhere, I would say, let's say, just to be safe, say from 6 to, or negative 6 to 6. So sort of go a little bit higher and a little bit below, just to make sure you capture the picture. So I'm seeing my sine function right now as we speak. And I'm seeing the quadratic function right there. Okay, so let me draw this out. So I have, this is my xy, okay? And we're going from 0 to 9. Actually, let me just change that a bit. So here's my y-axis. Here's my x-axis right there, okay? So I'm going to draw the blue. I'm going to draw the cosine function first. So it's going to go something like this, and goes like that. And then this quadratic function will be something like, I'm literally just copying this from my graphing calculator, and that's exactly what you're expected to do. So sketch the graph of f and g. So we've done that, and so this is the quadratic function. This is g right here, and this is f right here. Okay. All right. Consider the graph of f. So in other words, the blue one right here. The cosine function. The x-intercept lies between x equals 0 and x. Write down the x-intercept that lies between x equals 0 and x equals 3. So in other words, all you have to do is just find the x-intercept between 0 and 3. So in other words, that will be the first one over here, actually. So again, all I'm doing is just using my graphing display calculator and figuring out where that will be. So that's 2, 0. So this point right here is actually 2. So the x-intercept here is 2. And I'm done with this one. The period. The period is easy. This is our k value right here. So this is 5 cos of pi over 4x. So this is our k value. So if you remember, period is equal to 2 pi over k. So it's equal to 2 pi over 4, right? So this is equal to 8. If you just do this calculation, you'll see that it's equal to 8. So the period here is 8. The amplitude is clearly 5. So that's easy. Okay, now consider the graph of G. Write down the two x-intercepts. So again, you can just use your GDC and figure this out. And I think they pretty much expect you to use your graphing display calculator. So once again, you can do the 0, left bound, right bound. I'm literally just using my calculator. Oh, and it turns out, actually, so I made a slight mistake, I guess, in my picture. So it turns out that they actually intersect at the same point. So this is like that, and here's the blue graph, and here's the red graph, and they actually intersect at the same point. So one of the x-intercepts here is actually 2, so x is equal to 2, and now I'm about to find the other one. I'm just using my graphing calculator. I'm not doing anything fancy at all. And using my graphing display calculator, I figured out that this is actually 8. So it's x equals 8. The equation of the axis of symmetry. So this is 2 and that's 8. Really, the axis of symmetry should be halfway in between. So if one intercept is 2, one intercept is 8. So halfway in between 2 and 8 is actually 5, right? So this is x equals 5. So 2 plus 3 is equal to 5, and then 5 plus 3. So this is x equals 5 is actually halfway in between 2 and 8. So the equation of the axis of symmetry is x equals 5. You don't have to do part D because that requires calculus, so we're not going to touch that. Okay, so now we're actually at our last question. So let's figure this out. So here's some function a cos b. It's a cosine function. There's a phase shift and there's central axis. They're telling us the point of m. So at t equals 3. So t equals 3. There's a max value of 29 at m. So this coordinate is really 3, which is the x-axis, or in other words, t, and the y value is 29. So this is 3, 29. And then at t equals 9, so right here, t equals 9, they're saying that there's a minimum. So this coordinate is 9, because that's the t value, the x value, and the minimum is 15. So in other words, this is 15, so that's 15. So those are the coordinates of the max and min. Okay, so find the value of a. So notice a is the amplitude. Okay, so keep in mind, what is your max and min? Your max is not 3. 3 is just the x value. Your max is actually 29. Okay, what's your min? It's not 9, it's 15. Okay, because that's the y value. You always want to consider the y values of coordinates for your max and min. So if you remember the equation for amplitude, amplitude is simply max minus min divided by 2. So it's 29 minus 15 divided by 2, which is equal to 14 divided by 2, which is equal to 7. So A, in this case, is equal to 7. Now, second part, show that B is equal to pi over 6. Whenever they say show, you cannot use this as your starting point. This is your final point. You want to end up with B equals pi over 6. So how do we do that? So if you observe over here, if you have your max and min, this is actually just half a cycle. So from 3 to 9 is half a cycle. It's not a full cycle, because a full cycle would basically end up, let me use a different color. A full cycle would end up something like that, right? Because it's from here to here. So this is half a cycle. So from 9 to 3, in other words, this is a value of 6. So a full cycle would be another further 6. So a full period then is 12. So the period in this case, the period is equal to 12. And if you remember the equation, the period is equal to 2 pi over k. And k is basically our compression factor, or b in this case. This is really our compression factor, k, or b in this case. So in other words, I could have just written 2 pi over b, right? So 12 is equal to 2 pi over b. So 12 is equal to 2 pi over b. So b is 2 pi over 12, which is equal to pi over 6, and that's this one over here. So we've shown that b is equal to pi over 6. Find the value of d. What is d? Let's take a look at what d is. D in this case is the central axis. It's the central axis, okay? And if you remember the equation for the central axis, it's the central axis is equal to the max plus the min divided by 2. So what's the max again? It's 29. What's the min? 15 divided by 2. So it's equal to 44 divided by 2, which is 22. Let me just make sure that's right. 44, so it's 22. So D in this case is 22, and so this is equal to 22. So we're good there. Now write down a value for C. So C, if you observe, is the phase shift. So in other words, what is the phase shift? How far have we moved? Because cosine should normally start from the top and go down here, but we've moved it to the right. And this is a cosine function. So we've moved 3 to the right, as you can see over here. So the value of C, because that's the phase shift, is equal to 3. So C in this case is equal to 3. So we're done with that. Okay, so let's now move on to the rest of this. A transformation P is given by a horizontal stretch of a scale factor half, followed by a translation of 310. Let M be the image of let M prime, be the image of M under P. Find the coordinates of M prime. Now this sounds complicated. All it means is pick the value of M. So M in this case was, let's go back, was 329. This is the value of M right here, as we can see. This is 329. X value of 3, or T value of 3, Y value of 29. So you take the M and then you give this transformation. Where will it end up? What will M prime look like after this transformation? So if you remember, we can do transformations in like a really simple way. So our original points are 329, okay? And if we look at this transformation, it says it's a horizontal stretch by a factor of half. So horizontal means that it only affects the x's. So this means that all the x's will be multiplied by half. This vector over here means it's 3 to the right. So if it's 3 to the right, again, it only affects the x's. So it's going to be plus 3. What about the y's? The y's, so there's no stretch over here for the y's, so we don't have to multiply the y's by anything. It's just simply y. But we have to subtract by 10 because that's what that negative 10 means. So negative 10. So if I take 3 times half, that's 1.5. And 1.5 plus 3 is 4.5. So that's 4.5. Let's do 29. 29 will be subtracted by 10, so it's equal to 19. So the point M prime, so M prime, will be 4.5, comma 19. Okay? So again, this is just using transformations. We're doing a horizontal stretch with scale factor of half. That's why we multiplied the x by half. And then we added 3 because it was moved to the right by 3. And whereas for the y's, we just subtracted 10. So 4.5, 19, and that's why we get M prime over there. Okay, so that's how we do B. Now, the graph of G is the image of the graph of F under P. So what that means is they take this graph right here, they take this is your F, okay, and then they do some translations, which is they do some transformations, which is this transformation here followed by that, this stretching here followed by that translation. So after you do this transformation, you get G, right? So the graph of G is the image of F, image of the graph of F under P. So after you do the transformation, you get G. So find G of T in the form of G of T is equal to blah, blah, blah. Okay, so how do we do that? Okay, so keep in mind that, actually I'll just keep here. So remember, we're going from F to G, okay? So really, we need to, so G of T, if we write it in terms, oh actually, you know what, maybe I'm going to write F of T first. So F of T, we found the amplitude, which we said was 7, right? We said it was a cosine function. Remember, our B value was pi over 6, okay? This is x minus 3, okay? And then I believe it was plus 22. Am I right or wrong about that? 22. So 22 plus 7, 22 minus 7. Yes, it was 22. So remember, we got our values for A, B, C, and D right here, right? A, B, D, and C. We got them right here. And all I did was I took the 7, pi over 6, 22, and 3, and I just wrote them into the equation right here. So 7, pi over 6, 3, and 22. I wrote them into an equation right here. So g of t, if you look at the transformations, it's a stretch factor, it's a horizontal stretch factor of half, no vertical stretch. So what that means, it's f of 2, because remember, if it's a horizontal stretch factor of half, it means it's 2 over here. And it's translated to the right by 3. So it's, open bracket again, t minus 3, okay, and then minus 10. So what we're doing is we're stretching f by half in the x direction. We're moving all the x coordinates right to the 3. That's why it's t minus 3. Remember, it's the opposite sort of thing when it's within the function. And then it's minus 10 over here. So what that means is if we want what g of t is, what that means is we take this argument right here and we plug it right into this x. Actually, this is not x. This should be t. I made a small mistake here. This should be t. So this should be t. Okay. So what we're doing is we're taking this and plugging it right into that t. So in other words, this over here will be replaced. So basically that will be that over there, and then followed by this green thing over here. So let's do that. So this is equal to the 7, okay, because that's what f of t is. So 7, and then we have cos, okay, pi over 6, okay. Now we're going to replace that t with this argument over here, okay. I'm going to write that in blue so it's clear. So 2t minus 3, okay. All we're doing is replacing that t with this argument over here, okay. And then there's still this minus 3 over there left from before. Let me use black now. Let's go back here. So minus 3, and then you close it here, and then you close that bracket over there, and then there's this plus 22. Plus 22. So that's this whole red part that we've done over here. Now don't forget about this green part, because that's still part of g of t. So that's minus 10. Okay, so this will equal to, so now all we have to do is just simplify this thing. So it's equal to 7 cos pi over 6. This is 2t minus 6, 2t minus 6 minus 3, plus, this is going to be 12, okay? And this is going to be 7 cos, this is pi over 6, 2t minus 9, okay, plus 12. Now, you never want to leave t with a coefficient in front. You want to factor out this too. So what I'll do is I'll just expand this and then, no, actually no, I'll just factor out the 2. So if I factor out the 2, this 9 will be divided by 2 and become 4.5. So this will become 7 cos pi over 6 times 2 times t minus 4.5. Make sure that you understand this step because it's kind of crucial. All I did was I factored out 2 from this bracket over here, and if I factor out the 2, the 9 gets divided by 2 and so it's 4.5, because 2 times 4.5 is equal to 9. And I can simplify this in one more step, so it's equal to 7 cos, and now pi over 6 times 2 is really just pi over 3, and it's t minus 4.5 plus 12. And that's the expression. Now this is a hard question, so I really would like you to sort of go back, and if you don't understand it, just go back through the video and see how exactly I did that, because it sort of takes a little time to understand how that works. Okay, so we're done with C, and now let's do D. Give a full geometric description of the transformation that maps the graph of G to F. Okay, so if we're going, so this is a very, very tricky question, okay? This is part D. So if we're going from F to G, right, this is exactly the transformation that we did right here. If we're going from F to G, we stretched everything by half and then did a translation of 3 to negative 10. But what is this question asking for? This is saying, give the transformation that maps the graph of G to F. So in other words, it's asking us for the backward transformation. We're going backwards now. So if we're going for the backwards transformation, what we're doing really is, so usually we go reflect, stretch, translate, right? So let's actually do it as if we were going from F to G. So let's actually do it as if we were going from F to G. So if we were going from F to G, they said there was a horizontal stretch by half. Then it was followed by right 3 and then down 10, right? And then that's how you got G. Okay, so if we're going backwards, if you think about it, it's the exact opposite. So if we're going from G to F, instead of going down 10, we're going up 10. Okay, instead of going right 3, we're going left 3. And instead of doing a horizontal stretch of by half, we're doing a horizontal stretch by 2, because we have to do the opposite, and that's how we get F. So if we want to, the proper way to do this, the full geometric description, you would write, you're going up 10, and the order is important, because you're going up 10, you're doing the exact opposite. You're going up 10, left 3, then a horizontal stretch by 2, and that's how you would say that you would go from G to F. And that's D. All right, so that's basically the problem set for now. Hopefully that helped, and I'll see you in the next video. Thanks, bye.